Welcome back. This is Uhfgood, and we're doing Blender 3D Noob to Pro wikibook that was based around 2.5 or earlier. It said some of these were made. These images were made in 2.46. So now we're talking about the coordinates of child objects. Any object can act as a parent for one or more of the other objects in the same scene, which are then referred to as children. An object cannot have more than one direct parent, but parent objects may themselves be the children of other objects. If an object has a parent, its position, rotation, and scaling are measured in the parent's local coordinate system, that almost as if they're a vertex, as if it were a vertex of the parent, i.e., the position of the child's center is measured from the position parent center instead of the origin of the global coordinate system. So if you move a parent object, its children move too, even though the children's coordinates have not changed. The orientation and scaling of a child's local coordinate system are likewise measured relative to those of its parent. If you rotate the parent, the child will rotate, and perhaps revolve around the same axis. Parent-child relationships between objects make it simpler to perform and animate rotations, scaling, and moving in arbitrary directions. In Figure 1b, the teacup is the child object of the coordinate cross on the right. The cross is itself the child of an invisible parent, both its parent and child. In the cup's local coordinate system, it's not rotating, but as the cross on the right rotates around its z-axis, it causes the cup to rotate and revolve. Real animations would be much easier when the character holding the cup rotates. The cup changes position respectively. So, world parent. Parent serves as the source of the global coordinates for its child object. The child is the cup. The parent's orientation is shown with the colored arrows. Animation of the above. Oops. Okay. Oops, sorry about that. And there's the animation. So you can see as the parent rotates, the cup seems to move around. It's not actually rotating itself, but it's rotating as the parent is rotating. So that makes sense. And I don't know why I went up to the top. And we're already 3 minutes in, and I forgot to start this. And that's okay. View coordinates. Taking the viewer of the scene into consideration, there's another coordinate space, the view coordinates. Figure 2, the viewer is symbolized by the camera. The z-axis of the view coordinates always points directly to the viewer in orthographic projection. The x-axis points to the right, the y-axis points upwards, figure 3. Okay, so figure 2 and figure 3, projection plane, camera, I see. Okay, and view orientation. So this is what the camera is seeing, apparently. In fact, you always work in view coordinates if you don't set it any other way. In Blender 2.6 series, the default has been changed to global coordinates. View coordinates remain as an option. Interesting. It's particularly useful if you have aligned your view prior to modeling something. If an object has a slanted roof and you want to create a window to fit in the roof, it would be very complicated to build the window aligned to the local coordinate system of the object. But if you first align your view to the slanted roof, you can easily work in that view coordinate system. If you work in one of the 3 standard views, front, top, and side, the alignment of the view coordinates it fits the global coordinates. Therefore, it's quite natural to model in one of the standard views, and many people find this the best way to model. Presumably modeling by creating an object in like a direct orthographic view, and then when you go to perspective, everything's correct. Normal coordinates. Although Blender is a 3D program, only objects' faces are visible. The orientation of the face is important for many reasons. For example, in our daily lives, it seems quite obvious that a book lies flat on a table. This requires the surface of the table and that of the book to be parallel to each other. If we put a book on a table in 3D program, there's no mechanism that forces the surface to be parallel. The artist needs to ensure that the orientation of a face can be described with the help of so-called surface normal. It's always perpendicular to the surface. If several faces are selected, the resulting normal is averaged from the normals of every single face. The normal coordinates of the visible faces are drawn. This concept can be applied to individual points on the object, even if the points themselves have no orientation. The normal of a point is the average of normals of the adjacent faces. UV coordinates. In later parts, okay, so I'm going to go ahead and click on this, and they're talking about the normal. So, actually, I don't know about the the green and the red here, but the blue is basically your surface normal here. I'm not sure if, I guess that means it's pointing out, but basically it's perpendicular to that surface. So basically, that's what your surface normal is. Okay, later parts, for example, talking about textures, you will come across coordinates labeled U and V. These are simply different letters chosen to avoid confusion over X, Y, and Z. For example, a raster image is normally laid out on a flat two-dimensional plane. Each point on the image can be identified by X and Y coordinates. But Blender can take this image and wrap it around the surface of the 3D object as a texture. Points on and in the object have X, Y, and Z coordinates. So to avoid confusion, the points on the image are identified using U and V to label their coordinates instead of X and Y. We refer to UV mapping as the process of determining where each UV image point ends up on the XYZ object. Okay, so next module is the user interface view. And what are we doing here? We're about halfway through this video. Alright, so user interface overview, and this is where it's going to get a little bit tricky because it's quite a bit different. Quite a bit different than the current version of Blender. In fact, this talks about 2.79b, so obviously somebody has updated some of this anyways. Blender's user interface, the means by which you control the software, is not particularly easy to learn. However, it has improved over time and is expected to continue doing so. The current version of Blender software is 2.79b. You can download it from the Blender Foundation's website. So this has been fairly updated. Page was last edited on the 2nd of April 2018. So at least somebody is actually updating this a little bit. The tutorials in this section will familiarize you with the basics of the user interface. By the end of this section, you should be able to resize, split, and merge any Blender window. And we're going to figure out how to do that. I learned a little bit about how to do that. I almost kind of forgot in a way with the new interface, but we're going to see how that works. Change the type of any Blender window. Access user preferences. Access panels containing buttons and other controls. Change the viewpoint of a viewport. The viewpoint of a viewport. For those new to Blender, this is a fundamental section of the book. Advice on customization. Blender is a complex software package with many customizable features. You can customize the user interface to assign new functions to buttons and hotkeys. In fact, you can change almost anything to suit your style. However, this complicates the giving and following of directions. Recommending you adhere to the default screen arrangements of Blender in order to be able to follow the remaining parts of these tutorials. Blender ships with 4 to 5 screen content arrangements, which are suitable for almost any kind of job you'll want to use it for, from creating motion and animation to making games. Recommend leaving Blender's user interface in its factory settings while working through the Noob to Pro tutorials. At the very least, wait until you've mastered the basics before you customize the interface. We know you definitely will when you master it. Alrighty. So, next module, keystroke button and menu notation. Very exciting. Now we're actually getting to something here. Where is there we go. Okay, let's see. I'm on video number 3. There we go. As you read through these tutorials, you'll encounter cryptic codes such as shift plus LMB, the timeline, end frame, Describe action you perform using the keyboard and the mouse. The notation in this book comes standard used by the Blender community. We'll try to import those standards here to facilitate our studies. If you're reading this book online, you may wish to print this page for future reference. In addition, you can bookmark it. Okay, that doesn't really matter to us here. Hotkeys, notation, mouse notation, navigating menus, notation, additional resources. Okay, hotkeys. Most computer keyboards have number keys in two different places, a row above the letters and in the numpad numeric keypad to the right of the keyboard. While many applications use these two sets of keys interchangeably, Blender does not. It assigns different functions to each set. If you're using a laptop keyboard without a separate numeric keypad, this might cause some difficulty. You'll need to use the function key or do some things. That it's possible to indicate to Blender the type of keyboard you're using, but we would strongly recommend you use a standard external keyboard if you use a laptop for these tutorials. This will make your studies and usage of Blender much more straightforward and enjoyable. Often assumes that your keyboard has a numpad. If yours doesn't, the tutorial non-standard input devices for alternative ways to access the numpad's functions. So, so if it's a box with the key in it, press and hold the Alt Option key. Command, press and hold the Command Super key on Windows keyboard. The key bearing the Windows logo on Macintosh bears the word Command. Okay, Control. FN, function key, generally found only on laptops. Shift, the Shift key. Enter, press the Enter return key on the main keypad. I guess it's not a press and hold. So these are press and holds in the white, and these are just you press them, right? F1 through F12, spacebar, tab, A through Z, numerals on the numpad, other keys on the numpad. Delete, press the delete key, not num. The actual delete key. Down arrow, left arrow, right arrow, up arrow, not the numpad. Okay, I get it. Combinations involve holding down a key while performing another action with a plus sign. Thus, Shift plus Tab means to tab while holding down the Shift, and Shift Control F9 means to F9 while holding down both Control and Shift. Because you hold down the white ones, you just press and let up on the gray ones. I get it. Blender uses 3 mouse buttons and a scroll wheel if you have one. If the mouse has only 2 buttons, consult the tutorial on non-standard input devices. Alternative ways to access the functions. Okay. Click with the left mouse button, click with the right mouse button, press down on don't turn the scroll wheel or middle mouse button. Scroll, turn the scroll wheel in either direction. Mouse and keyboard actions are often combined. Shift plus right mouse button means to click the right mouse button while holding down Shift. Navigating. Okay, so I'm gonna cut it here, and we'll see about navigating menus in the next thing. So I will see you then.